All right, question 52 says solve the system of equations below using any method, but not matrices yet. Although that would be interesting. This first one, A, I was tempted to try and do elimination. Then I'm noticing like, wait a minute, y is by itself right here. So I'm going to use substitution, and I'm going to replace the y in the second equation with this expression I have for y in the first. So I'm rewriting this second equation. This second equation says 6 times x minus 5 times y. But for y, I'm going to use 3x minus 3 because y is equal to 3x minus 3. You can see it right there. 3x minus 3 is the y. And then that equals, oh my goodness, OneNote just got very unhappy with me and it just reset itself. Hello OneNote, come back. There it is. That 3x minus 3 is equal to 12. Perfect. So again, you can see the 6 times x, the negative 5, the negative 5, the y. Playing the part of y is not y, but 3x minus 3, and then equals and 12. So cleaning this up a bit using the distributive property, I'll write 6 times x minus 15x, and then plus 15 equals 12. 6 times x minus 15x, that looks like about 9x, and then plus 15, I'll take away 15 from both sides. That's going to give me like negative 3. 12 minus 15 is negative 3. So x is negative 3 over negative 9. X is 1/3. And if x is 1/3, let's figure out y by plugging that 1/3 into this original equation. The original equation was 3x minus 3, right? It was 3x minus 3 is y. So I'm going to feed the 1/3 into this. 3 times 1/3 is 1. 1 minus 3 is 2. So y is equal to 2. So my solution for A, I believe, is 1/3 for x and 2 for y. Of course, you would be very silly to just take my word for it. I hope that you consider plugging those in and seeing if I'm right or wrong. And of course, if I made a mistake there, please let me know about that. Next system of equations. I'm going to solve this using I mean, I kind of want to do elimination, but it kind of looks messy. So I'm going to do it anyways. To solve using elimination, I believe I'm going to multiply this top equation through by a 3, and I'm going to multiply the bottom equation through by a positive 2. And that's going to make it so that my y's ends up being opposites, right? These are going to be opposites, and when I combine them, the y variable will eliminate. So let's distribute the 3 across the first equation, hitting every term on both sides. So that equation is going to become 9 times x minus 6 times y equals 90. And then let's distribute the 2 across the second equation. So I'm just pushing that factor of 2 across it. 4 times x plus 6 times y. And that's going to equal negative 38. And if I combine these two wonderful equations, I'm going to get 9x and 4x, which is 13x. And don't laugh, it's late in the day, and yeah, I'm taking the number 90 and I'm subtracting a number that's not quite 40. It's 38. If it was 40, I would get 50, but I'm only taking away 38. So since I'm only taking away 38, it's going to give me the 52. Oh, and I think that's divisible by 13. Whoop, not 53 though, 52. 52, I believe, divided by 13 should be the number 4. So x is the number 4. That's part of my solution. Now we must calculate y. How do I get y? I'm going to get y by plugging it into one of those two equations. I guess I'll use the top one. The top one. So the top equation was 3 times x. Playing the part of x is my found value of 4 minus 2y equals 30. So you can see I'm using the original one, not the one that I multiplied by 3. So 3 times x minus 2y is 30. That's 12. So negative 2y equals 30 minus 12 is 15, 16, 17, 18. And then 18 divided by negative 2 would be negative 9. So I believe my solution to B is x is, as an ordered pair, 4 comma negative 9. X is 4, y is negative 9, and please plug those in and check. It's so simple. And if I'm wrong, of course you get the extra credit. Just come talk to me.